Okay. So I think I just started recording. So sorry, I'll just go through this once again, very in a very rapid good pace. So I'm actually I just started recording because this has to be put on the channel as well for people who want to see it again. So this week was about packet classification. In packet classification, hierarchical tries and set pruning tries were the most looked at, and we'll be looking mostly into these two. And the context behind packet classification was routers, and then these routers have to make decisions on whether to send a packet to the next hop or not. So how do you compare these packets and their IP addresses or whatever it is to what is already there in the router, so that you can make a decision whether to send it forward or to not send it forward. Right. So the first is when we directly went into the question. So the first question is, during the lookup operation, which of the following tries avoid backtracking? This is directly from the videos, because set pruning tries and grid of level tries replicate nodes just to make sure that that we don't have to backtrack, or rather, set pruning try does replication of nodes, and grid of try, instead of replicating nodes, it sends pointers from from one terminal node to the other. So that is why the answer for the first question is B and C. Right. So what is backtracking? It's when you come down and then you go back up. So it's like you come down and then you go back up. So yeah, so this is what backtracking is. And number two is, which of the following try neither requires backtracking nor rule replication during the lookup operation? So the answer here is grid of tries, because hierarchical try requires backtracking, multi-level also requires backtracking, set pruning also requires rule replication, and the only thing left out is grid of tries. Right, so the answer is D for second question. Third question is, if we consider a three-dimensional set pruning try with D1, D2, D3, and maximum field length for each field is 4, and there are 5 rules. In the worst case scenario, how many times will the rules need to be replicated? If you want to close your eyes and if you want to answer this, you just need to raise the number of rules to the power of the dimensions, and that's what it's done here. So n to the power d, which is 5 to the power 3, which is 125. This is directly following from the videos. And now, which of the following packet classification schemes is the most efficient in terms of searching time? So the answer to this question comes from your comes from the previous conclusions that we made, because we know some of them avoid backtracking. So if you avoid backtracking, then that means that you are doing less number of comparisons. Why is it less number of comparisons? Because in a tree, if you take it like this, you compare, and then you backtrack, compare, backtrack, compare. But if you replicate the nodes, then if we go down a particular path and if you don't find a match here, then that means you can be sure that you're not going to find a match anywhere else, so you can just stop searching there. And that's why the searching time here is most efficient. And which are all the techniques that don't need backtracking? It is set pruning and grid of tries. So the answer is set pruning and grid of tries, which is D. Now, yeah, so this is where we were. Yeah, that's where we were, and there was just a short recap, just because I had failed to record it, and I thought I should give a context before. So we are here right now, where we are trying to build a set pruning try. And the biggest question when we start building a set pruning try is, which of the rules should we duplicate? Is there any particular is there uh, a blind method to it? It's like in the sense that this is A, this is B, this is C, and then You just follow A, B, and C, and then you should be done with it. Something like that, Yes, the answer is yes. It's not completely a blind method, but yes, it makes your life easier and to figure out which of the nodes have to be replicated, or which nodes or which rules have to be replicated. Right. So in that conquest, we started drawing, and we had so far first. So the rule is, of course, you can see this in the video as well. So first we add dimension by dimension. The first dimension we're adding. In the first dimension, we have added 0, 0 star, which is represented by this and this. Okay. And then next we had just added 1, 0 star. So this is where we stand. And yeah, 1, 0 star. And then we and then now next we're going to add 1, 1. Right. So 1 is already here, and then we go for another node, and then this is 1. And I'm shading it just to give context that, okay, this is one of those nodes which are accepting something at least. Right. So 1, 1 has been added. The next is 1 star and 0 star. Right. So 1 star. So 1 star is already there. So you have 1. So from here you're coming over here, and this is basically 1 star. So the moment you see a star, you can shade it, because this is one of those nodes which will link or point to the next dimension. That's why I'm shading this 1 star. 0 star is also supposed to be shaded. So 0 star is this, and then star is also, so the first one is always star, so you're supposed to shade it. Now why we're shading it? So all the shaded nodes here will have further connections for dimension 2. So in this case, all of it is there, but if you saw some examples in the videos, not all of the nodes will link to the next level, the next dimension. So this is D1. Have any questions now, you can always ask. If you want me to explain again what these colors mean, you can always be free to ask. Okay, so dimension 1 has been added. Yeah, please go ahead.
How to find the height of the tree?
The height of
Sir, we have to draw second one also, sir.
Yeah.
Please, can you take one example and let us know? There is a confusion in that.
Yeah, exactly. You joined just now?
Yeah.
Right. So there were 2 questions, right? One is height of the tree. Okay. The height of the tree should be equivalent to the yeah, it's supposed to be 101. Yeah, so the maximum height of the tree will be
3,
equivalent to 3.
3 means that is number of nodes from including root node or what?
No. 3 is not the answer. I mean, 3 was just suggestion. See, we have not finished doing the tree yet, the try yet. So it's just the first dimension that we've added.
Okay.
So if you see the sequence like this, right, there are 2 nodes here, and then there are 3 nodes. There are 3 nodes here, right? So the height of the tree would be something around, let's say, at least 5. Plus, if we consider the intermediate node, plus 1. And I mean, we'll come to the height of the tree once we've drawn the whole tree, okay? And then we'll discuss that part.
Okay.
And yeah, so and someone was asking, there's a confusion, right? And I think is this where your confusion is? Which rules do we duplicate? Most probably this is where the confusion might be, right? I don't know who was asking. I think it was Biradar, or is it Karumanshi, Hari Babu? Sorry, I don't know. One of you both had this question. So
Sir,
if you can
both
exact.
R1 and R2 both are same, sir.
Oh, here, yeah, R1 and R2 both are.
The rule one, the first distance, the rule 1 and rule 2 both are same, sir.
Yes, R1 and R2 stop here. You're right.
The first distance.
Yeah, first is R1 and R2 is represented by this and this 0 and a 0. Okay. Okay, I think I'll trace the whole thing again. I'll trace it again. It's okay. Fine. See, I'm doing it very mechanically. So first we have to add D1. Add D1. Draw. Let's worry about what it is. Okay. Next 0 0 0 0. Right. So this for a 0 and a 0, you've added R1. Okay. I'm just looking at R1 right. So you've added R1, and once you see a star, see a star, shade it. You can shade it. Now, why are we shading it? Whatever you shade, you will have to extend it further for the next level also. Okay, so 0 0. So far, so good. Now, so far, so good, Hari Babu. You understand 0 0 for now? 0 0 star. Is it is it okay? Like 0 0, you're okay with 0 0 star? Oh, okay. So is this okay? 0 0 star? Is my voice still not audible? Hello. Hello. Oh, I think
Sir,
it's pretty clear. Yeah. Okay. Right. So I'm assuming that 0 0, the first one you've understood, and as you said, rule R1 and R2 are the same in this case, at least as far as the first two rules are concerned. So for both R1 and R2, this is the same. The rest of it now 1 0. So there's 1, and then I have a 0. This is 1, and then this is a 0. And the moment you see a star, just and then 1 1. One, and then the moment you see a star, shading it now, and now see this is 1 star, right? This might get a bit confusing, but because this is 1 star, this is already there. Yes, it's already there. Now the only thing that this 1 star is going to tell you is from this particular node you have to extend it. So for that you are going to shade it now. So which is what is 1 star here? 1 star is this. That's shaded, and 0 star is over here, and then star is over here. So in that sense, let me just annotate all the shaded ones as to which rule they belong to. Right? This is R3, and this is R4, and this is R5, 6, this is R7. This is what it is. This is not complete. Just I'm just putting you. I think there's okay. There are these 5. I mean, and this is basically the first level, right? So we've added this, and this. And for every shaded node, we have to add a second level, and that second level is basically dimension 2. Now the confusion will start happening from here probably. So now all of this is again explained in the videos, so this is pretty straightforward, but nevertheless we still start adding. Okay, I'm just putting this in R1 and R2 here. So how do we add? Now we go back to the same, we go back to D2 over here, and then we start adding the first one. First one is 0, 0, 1, right? So the 0, 0, 1 is connected to R1. So where is R1? I have marked R1 here, correct? So from here we add a auxiliary node. So this is basically called an auxiliary node. Again, this is all in the video. So this is a no cost node, let's say. It's like a connector. So from here it goes to 0, and then a 0, and then a 1. So this is 0, 0, 1, and because there is a star here, you are going to shade this, and then you're going to write this is R1. Does this make sense? Okay. So far there are no confusions, so it should make sense. So what this essentially what this means is, if some packet has 0, 0 in D1 and then 0, 0, 1 in D2, so it matches here and then it comes to the auxiliary node, and then it goes to here, and then finally it has an accepting state called R1 here. So that's what it means. Now let's add the second one, which is 0, 1 star. Right? So 0, 1 star is also once again attached to R2. So where is R2? R2 is over here, correct? R2 is over here. So now I have to just add 0 and then a 1. So I've already added a 0 here, and then I need to add a 1 here. So what do I need to add? This is basically a 1, and then I shade it. Why do I shade it? Because there is a star. This is just a mechanical thing. You just keep it in your mind like this. R2. And yeah, so the next thing is to add 1, 0 to R3. Where is R3? R3 is over here. Okay. So for R3, step 1, just add this auxiliary node. Right. And add 1 and a 0. Right. So for this, from here, so 1, this is going to be a 1 and a 0. And then you can shade it now, because this is R3 star 1, 0 star. So this is R3. Next is 1, 0, 1. And what are we attaching this to? R4. Where is R4? R4, it's here. And what do I have to do? Once again, I have to draw this auxiliary node, and then I do 1, 0, 1. This is 1, 0, 1. this is 1, 0, 1. And because there's a star here towards the end, you shade it, and then you say it is R4. Okay. The next is R5. So R5 starts from R5. Where have we marked R5? We have marked R5 over here, right? It's somewhere over here. It's over here. So now, okay, there is a column space. I'm just putting it over here like this. So R5 has a 0 star. So this goes with this, and then it has a 0, and it's an accepting state, which is you shade it. Then you write R5. Then for R6, it's 1, 0, right? So, but then you're adding it to the 0 state, which is R6 over here. So once again, you extend this down, create this auxiliary node, and then what do you have to do? We've already put this. Now we're trying this. Now we'll put 1, 0 star. So it's going to be 1, 0. Which must move left? For which one? Did I make mistake? Mm, you can unmute and speak, or are you not able to unmute if you want? R5. R5 must move left. Yes, you are right, and it has moved left over here, no? So it's 1 and 0, 1 star and 0 star. So 1 star is this, and then you go here, and then you go left. So this is basically a left movement here, 0, right? As I mean, you can be a bit more elaborate, and you can unmute your mic as well, and you can let me know your exact question. But yeah, I understand your concern. Basically, you're basically saying that because R5 is 0, it must move left, and just take a look at this and then try to trace it. And it is going with 1 star. This is 1 star, and then from 1 star we are moving to this auxiliary node, from where this is 0 star, right? Okay, is it clear? And so, I mean, I think maybe because I've drawn it separately like this, like I've taken it like this, and I've made sure the second level all starts from the same height. Maybe it's slightly different from what was explained in the class videos. I'm doing this just to make it more clearer. I mean, you can draw it in any way that you want. Right? So now, so we were right now adding R6, 1, 0 star. So this is 1 and then 0, and then this is R6. And now finally R7. R7 is star. Where is R7? I've marked R7 over here. So from here, I need to add an auxiliary node, and then I have to do 1, 1. Now I'm doing 1, 1, 1, and then another one because there's no space. Okay, that should do it better. This. So this is 1, this is 1, and this is R7. So this, if you take a snapshot of this, so this is basically your hierarchical trie. So far we have created the hierarchical trie. But now comes the question of which are all the nodes that we have to replicate. Now, node replication, the reason for it, tell me, yes. Okay. So node replication, it has to happen because you want to avoid backtracking, right? So the question is, which are all the nodes that I have to replicate? How many nodes do I have to replicate? Right. So I'll give you a simple, not a trick or anything, a shortcut or anything. So this is not following logically. This is like a blind method to find out which are all the nodes that have to be added, right? So step 1, find out where your star is. Okay. Method to find replicatable nodes. So first go to D1 and find star, right? So where is D1? D1 is this, and then you found out the star is over here. Okay. So whatever is towards the right of the star, the next dimension of the star. So this you have to make sure that it is added to every one of these. This has to be added to every one of these. Here, 2, 3, 4, 5, 6. Right. So essentially, what that means is you have a star, which means it could mean anything. Any of these above combinations are covered by the star. If you that makes sense. So because you've put a star here, it could mean any one of the above, right? It's 0, 0 star is also represented by a star. If you had studied automata, and I think this is very similar to that. If it's 1, 0 star is also covered by star. 1, 1 star is also covered by star. 1 star is also covered by star. 0 star is also covered by star. So logically, any of these specific inputs should also accept 1, 1 star. So how do you do that? We need to add this 1, 1 star to every one of these other rules. So 1, 1 star is what? R7, right? So for that, let us start adding. So we are adding R7 in multiple places right now. So R7, which is 1, 1 star, let's try adding it to R1. So where is R1? R1 is over here. So this is R1. Again, once again, this is R1. So to R1, I'm adding 1 and 1 star. So for this, I'll take a completely different color probably. Yeah. So it is to R1, I'm adding 1 star. Got it? So there's going to be 1, 1, and then star thing, and this is R. R7. Okay, why is it R7? Because it's what we're adding is basically R7. This particular 1 star option is what we're appending to R1 here. Right? So next, let's try adding R7 to R2. Now, why are we adding R7 to all of these above? That's because star basically covers all the above here. So you have to make sure that this particular sequence is available to accept. And in a blind way, if you want to see it, whatever is there to the right of star, add it to every one of the above. Correct? That's it. That's a blind way of looking at it. Logically, if you think about it, it will also make sense to you. So 1 star is added over there, right? So this is the first node that we have replicated. Now let's try adding this to R2. What is R2? R2 is also 0, 0, right? R2 is also right here. So in fact, by adding it for R1, we have also added it for R2. So we have covered these two right now. Let's try adding it to R3. So where is R3? R3 is over here, correct? So for R3, we need to add 1, 1. So R3, there is 1 here, and then a 1. This is R7. So it's 1, 0, 1, 1. 1, 0, 1, 1. So have we added this R7 to R3 also? Yes, we have. So we have added another application. Now let's add this 1, 1 to 1, 1 star, which is R4. Where is R4? R4 is here. R4 is 1, 1. Now we need to add another 1, 1. So there is already another 1, and then I add a 1, and then another R7. So 1, 1, 1, 1. Another replication has been done. So this is done. Now, does this make sense, or is it not making sense? If it's not making sense, I can explain it a number of times. It's completely fine. Okay, because that's what the session is for. You can feel free to go ahead and unmute your mic and speak. We can go through the same thing again also a number of times. Because I feel this is a very this might be a question in one of your exams, because I think most of the questions are based on this also. Okay, so now we've added 1, 1 to R4. Now next we are adding R7 to R5. Where is R5? R5 is over here. So R5 is basically 1 star. So 1 star, 1 star. Do we have 1 star, 1 star here? No, it's not there. So it should be 1 star and then 1 star. So this is 1, this is 1, and then R7 once again. So 1. So this is 1 star and then 1 star. Okay. So for R5 we have added. Now next is R6. For R6, it's 0 star, 1 star, right? So where is R6? R6 is over here. So it's 0, star is here, and then 1, and then another 1, and then R7. Right. So now we have added how many R7 nodes? 1, 2, 3, 4, 5. Right. So we have added 5 are 7 nodes. So we are done with adding our 7 nodes. Right. So next, now the step 1 is done. Step 1 is a very it's like a very straightforward thing. Wherever there is a star in the first D1 dimension, you have to add whatever is towards its left onto every other node there. So that is done now. So next is going to involve some manual work. So the step 2 or the second thing that you have to do is you have to add all the nodes, all the D2 nodes to those covered by D1. So what I mean by that is you check here, okay, is there anything above in D1 that is covered by this 0 star? In the sense, if any of the above is a subset of one of the rules below, then you'll have to add it to that particular subset. So that is what it is. So that is what this means. Okay, so it's better to always go from the smaller one, because the bigger one can never represent the smaller one. The smaller one can represent the bigger one. Right. So I don't know if I'm making sense. I don't know if I'm making sense to you. I'm making sense to myself, of course. So I'll just give you a moment. Just try and see if you understood the first step. The second step, I'll just be back in 2 minutes, right? So what was I saying? I was basically saying that look at D1, the dimension D1. The star, it covers everything on the top. Correct. It covers it. It covers it in the sense it is a superset of everything on the top. Meaning it represents everything on the top as well. By top, I mean R7 also represents R6, R5, R4, R3, R6, R5, R4, R3, R2, R1. Why? Because star could also mean 0 star, right? Star could also mean 1 star. That's what it is. So and that is why we added 1 star to every one of the nodes above. So this is default. Close your eyes and do this. But for the second step, you need to think a little bit more. You need to see which of the rules are covered or will cover the other rules on the top. So let's look at R6. Okay. So if you look at R6, 0 star. So 0 star is also represented. So 0 star, is it represented by R5? No. In the sense, 0 star is not represented by R5. And 0 star, is it represented by R4? No, because 0 star starts with 0, that is starting with 1, 1. So that's not the case. Is there any commonality that is? And then is 0 star, can that also mean 1, 0 star? No, because it's starting with 1. But can 0 star mean R2? Yes, because 0, 0 star and 0 star are pretty much equivalent. Right? Because if 0, 0 star is accepted, then 0 star is also accepted. And similarly, this is also the case. So which means Now you know that this 1 0 has to be added where? This 1 0 has to be added to R2 and to R1. Simple. This is pretty straightforward. So where is R1 or R2? R1, R2 is right here. So for R1, R2, 0 0 and then 1 0, right? 0 0. There is already 1. And then I don't have space here, so I'm putting another node here. This is a 0 and this is R5. Because of lack of space, I've put it here like this. So you have added 0 0 1 0 to where two rules R1 and R2. Done. It's pretty simple now. And now you have to repeat this process. Now we saw R6, correct? Now we saw R6, and we added, sorry, and then we added R6. This is R6, sorry. This is R6. Now we added R6 to R1 and R2, right? Now let's check R5. 1 star. So 1 star, compare it with R4 and see if 1 star also means 1 star. Yes, it also means in the sense 1 star can also contain 1 star. So we have to add 0 to this. And now compare it to the next one. 1 star, can 1 star be represented by R5? Yes. The reason is 1 followed by 1 star means 1 followed by anything. So 1 star is also covered by 1 star. So you now have to add the 0 star both to R4 and to R3. Right? So whereas R4 is here, and R4 is what? R4 is 1 star. So 1 star is here. Then now I have to add 0 star. 1 then you put a 0 here, then you shade it, and then this is R5. So 1 and then 0. And the next R3, where is R3? R3 is over here. So R3 is 10 star, to which I'm going to add a 0 star. So it's 10 star, and then to which I'm going to add a 0, and then once again R5. Okay. So, and of course, obviously 1 star is not covered by 0 star, 0 star, 1 star. So we have added R7, we have duplicated R7, R6, R5 now. Let's check R4. So R4, is there any commonality here? No. Here, no. Here, no. So no need to duplicate this. R3, any commonalities? Any commonalities? No. No. So we can basically we don't have to add it. Now, R2 and R1 are one and the same. So we don't have to do it for these two also. So this is a very intuitive, or no, I wouldn't say intuitive, it's a simpler way where you can mechanically go from the bottom to the top and then check which are all the ones that you have to add. The only thing that you have to check is what is common across this previous dimension, based on which you have to replicate the other nodes. That is it. Very, very simple. Now, what is the question? The question is, to build the set pruning data structure, which of the following nodes / rules are duplicated? Which of them are duplicated? No, just give me the answer now. The answer is right in front of you, basically. So it's R5, R6, and R7, right? So R5, R6, and R7. So the answer is C, D, and E. This is what it is. If you have any questions regarding this, feel free to uh, ask me. Okay, so let's do another question. On this same topic. Right. So this is also very, very similar to the previous one, right? So let's see. No, I think I can just breeze through this a little bit faster. So what is, so instead of D1, D2, they're giving F1 and F2. That's basically nothing but the two dimensions of this. So what is the first step? We start adding F1 or D1. So 0, 0, 0, star. So this is 0, 0, and this is star. So this is R1. And the next is 0 star. So this is 0 star. This becomes R2. And next is R3, which is 1 star. This is going to go like this. And then this is R3. Next is 0, 0 star. R4 is 0, 0 star, right? So R4 is 0, 0 star. So this is R1 and R4 as well, this one. R5 is 0 star. So this is R2 and R5. And R6 is the star itself. So here. So this is R6. So this is F1. Okay. So now we add auxiliary nodes for all of these. I think we can just like that start adding these auxiliary nodes. Because all of them do have connections, right? Right. So now we're going to add F2. Right. So now what do we add in F2? To R1, I need to add 0, 0 star. So R1 is here. So here it's 0, 0 star. 0, 0 star. And this is R1. Right. Next is 0 star. To R2, I'm adding 0, 1 star. That is R2. R2 is over here. So 0 and then 0, 1 star. 0 and 1. 0 and then 1 star. This is R2. And then the next is R3, which is 1 star, 0 star. So where is R3? R3 is here. So 1 is here. And then I just need to extend it to a 0, 0, and then a star. This is R3. Next is R4 is 0, 0, and then another 0. So R4 is basically here, and then I'm adding a 0 star to it. So a 0 star is nothing but we already have it. So we just need to shade it over here. And that becomes R4. And next is R5. So you are adding 1, 0 star to 0 star. So where is R5? R5 is here. So from here it needs to go to a 1 and then a 0. 1, then a 0. Zero. Yeah. So 0 and then 1 and then 0. So this is R5. The next R6 is just 1 star. So where is R6? This is here. So going to be 1. So this is R6. So now we have drawn the hierarchical trie. Next, we need to convert this hierarchical trie to a set pruning trie. So for this, what were the rules, right? First rule was whatever is there for star, you need to replicate it for everything else. I'll take a different color now. So basically, I have to add this to this, 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 right? So R6, basically now I'm adding R6. Now R6 is 1 star. So let me see if uh, 0 0 star is going to be requiring R6 instance. Where is 0 0 star? Where is R1? R1 is here, and from R1 1 star. So it's like 1 this thing, and then this is R6, and then R2. Where is R2? R2 is here. So 0 star and then 1, 0 star and then 1. Zero star and then 1. Yeah. So now this becomes another accepting state called R6. Now the next thing is R3. So 1 star and then 1 star. So R3 is 1, and then we have there is 1, and then we have another 1. Right? So we need to put another 1, then replicate this as R6, 1 star. This is for 3. Added this, then R4. That is R4. R4 is over here again, and we have already added it for R4. So I think it's going to be right where it is. R4 is nothing but 0 0 star, and then we have added 1 star to it. It's fine. So R5 is here, and we've once again added for R5 as well. There it is. R6 is already added. So R6 has been added. Now next, let's look at R5. So the 0 star, if you look at the 0 star, this is both covered by R4 and R2 and R1, right? So we have to add it to all of these 3 places. Potentially, we'll have to add it to all of these 3 places, let's say. So now let's look at R4. If you look at R4, does R4 have 0 star? Yes, there is 0 star. Right? So we don't have to add R5 to that particular line. So this is already covered. And R2, so where is R2? R2 is 0 star. And then once again, I need to see if I have oh, just I think I made a mistake. So we have to add this to R4, right? So R4 is here, and then I have to add 1 0 to it. So there is 1, and then there is a 0. Then I'm adding R5 to this. Okay, yeah, we're adding that. Next, we are trying to add this R2, R2, R2. So 0 1 0 star. So R2 is 0, and then 1. So there's 0 here, there is 1, and then there is 0. So it already goes to R5 over here naturally. So we don't have to worry about it. It's already there. Right? Now, to R1. So R1 is where R1 is here. So R1 I've already added 1 0. So R5 is done. It's added. Now R4 and R1 are the same, and none of the above is going to cover R4. So no need to add R4. We've added these two. No need to add R4. Next is R3. So is there anything that is common between R3 and R2 and R1 or any of these? Absolutely not. So I don't have to add R3 as well. And next is R2. So R2 is covered by both this one and by this one, right? And by this one. So potentially we'll have to add R2 here, R2 here, and R2 here. Why? Because it appears to be covered. So let's see. Let's try adding R2 to R1. So R1 is 0, 0, and then do we have this 0, 1 star somewhere? 0, 0, 0, and then 1. So this is R2. So I've added it over there. So let's try adding R2 to R4. So R4 is here. So to this I'm adding a 0. Sorry, to this I'm adding a 0, 1. So R1, R4, so there is 0, and then there is 1. So I've already added this. This is also done. So to R5, let me try adding 0, 1. So R5, there is 0, and then there is 1, and this becomes R2. So it's already here. So that's it. We have covered everything. So we have added, we have duplicated R2. And then R1 need not be duplicated because it's the same case as R4. Essentially, the intuition here is you have to add these second dimension nodes to all of those first dimensions which have some commonality between, which are basically covered by the ones on the left side. So what is the answer to this question now? The answer to this question is R2, R5, and R6. The answer is D. This is pretty much how you answer these questions. So I'll leave you at this. If you have any questions now, you can unmute and you can ask. So I'll be around, and this is pretty much what I wanted to cover this class, because this is the most confusing part of it, where you have to find out which of these nodes have to be duplicated. And yeah, so this is a very easy way to find out which nodes are to be duplicated, and you don't even have to draw these completely. So you just have to take an answer. You'll know which one to even add even before going to look at the tree. It's like I have to add this, and this. Just check it out like that. So if you have any questions, you can ask me. If not, then we can end this session and we can move on to the next one. Uh, okay. Okay. Can we get lecturer notes for this session? Yes, you can get lecturer notes for this session. I'll tell you where you can get it. I mean, for today's session, I'll be uploading it maybe by today or tomorrow. Let me just tell you where you can get it. I think for both the weeks, it's there. Okay, so that's the answer for the first question. It'll be available in that sheet by today or tomorrow. Okay. One second, sorry. Yeah, so draw the diagram. Once after that base option, we get answer for this after D2. Oh, are you asking for the first question, Haribabu?
So after considering the second distance, R2, R5 and R6 are the leaf nodes, sir. Hello.
R2, R5, R6, correct. Yes, yes.
But
These.
there is an R3. R3 is the first level. So don't be. I think my knowledge based on my knowledge, no need to consider the R3, sir.
You're saying
So
R3?
here almost all R2, R5 and R6 are the base. They have the same level.
Correct. Okay, okay, okay. Same level in the sense you're talking about this F1, F2, or is it like
for these options? For whatever we are getting the options, there are 4 options, no? R2,
correct, correct.
R5. Yes. No one match for the R1 regarding the rest of ones, sir. But R2 and R5 are the same level.
Uh-huh. Right. You mean it's there. We are duplicating these nodes. They are the same level.
Just I'm guessing like that, sir. Just I'm guessing like that.
So you're saying that okay, we can deduce like that. You're saying that if it's in the last, if these are things, the other ones have
Based
completely
on the
correct.
construction of the diagram, that is the way to get the answer like that.
Okay, okay, okay. Yeah. So once you have once you've drawn the diagram, then you don't have to do any deduction here. You see my point?
Yeah.
Once you diagram, why do you have to reduce?
The
We
first
should
level, that is the R3, sir. After that, we are so in the second level, we are giving another level, na?
when you say first level R3 is here, okay? First level.
R3 is the 1 star.
Correct, correct. Yeah, correct. You're right.
The second level, they are the only 0 star. But we are in R2, R5
Yeah.
are both are same level.
Okay, okay. So again, in this case, I think what you're trying to say is you are sure that R3 will never be a part of the duplicated node. That's because it is 1 star, right?
Yeah.
So I think in that sense, even without drawing the diagram, you can deduce to some extent. Totally remove R1, I mean B and C.
Yes, I'm guessing based on the options, sir.
Now based on the options, correct? Yeah. Again,
Yeah, that is right.
yeah, once you start drawing these diagrams, you can always deduce without drawing the diagram also. But I would not recommend that because there are always some corner cases which you will miss.
The better way for this one to draw diagram correct carefully, then only get the answer easily.
Yes, yes, exactly. All right.
Even if we have a little bit of confusion, we are getting the incorrect answer.
Yeah, true. So that's why it's better to draw because we can never know. Some places you'll think that it's not going to be added, but it will be added in some other places as well. But yeah, so that's conclusion. Thanks for the question. Okay, then. So I'm concluding the session now. We can stop recording and